Good day everyone. We will discuss about SQL Server predicate pushdown in this video. Let's get started. I'll be using a database called JBS Wiki. I'll be creating a table called table 1. Table 1 gets its data from a backup table called table 1 underscore backup. It has a cluster index on column 1. Additionally, it has a non-cluster index on column 4. Column 2 and column 3 is also included in the index. So what we'll do, we will execute this simple select query, which basically selects column 2, and this is the predicate that is present for this particular query. So let's execute that with the actual execution plan. And then let's look at the index seek operator here. So what we can see here is like SQL Server estimates 31,569 rows, and it ends up reading close to 1,76,480 rows, and then it actually returns close to 10,912 rows. So in this case, SQL Server does some extra work. That is, even though it has to return only 10,912 rows, it couldn't pinpoint those rows and just read those rows, but instead it had to do some extra work. That is, it had to read close to 1,76,480 rows, and then it out of those rows it returned only 10,912 rows. So this is something that happened for this particular query when SQL Server used this IX underscore test1 non-cluster index. The query optimizer always evaluates predicates on top of a table or index scan or maybe range operation. So some part of the filter predicate may match an index key and may therefore be used to run an index seek or maybe a range scan. So that pushes a predicate down to the storage engine. Which is basically your predicate push down. So it only needs to read the required set of data. The remaining parts of the predicate are known as residual and may be evaluated for each row the index seek outputs using a filter operator. So what we'll do now is like we will look at the logical reads for this particular query. So in this case, we have a logical reads of 490. And this can be attributed to the extra work that the SQL Server had to do. Like it had to read close to 1,76,480 rows, but it had to return just 10,912. So since we had to read this extra rows, what we are able to see is like the logical reads for this particular query is close to 490. So now what we'll do is like we'll create a filter index, and we will execute this particular query. This query is same as the last one. The second query is like has a change in the predicate column 3, which is basically column 3 is equal to 501. So let's execute this query. Let's look at the execution plan. If I look at the execution plan, the estimated number of rows is close to 10,912. And the number of rows read is also 10,912, and the actual number of rows for all execution is also 10,912. So it's a perfect estimate, and we were able to just read only the required rows, and those rows were displayed. So SQL Server did not do any extra work. So this is a perfect example where if you have a proper index for that particular query, the amount of work that SQL Server does is like just to the point. It will not do anything extra or anything less. It would just do to the point what is required. Now, if you look at the other query, it basically had a predicate of column 3 is equal to 501, and since the filter index had as a predicate filter of column 3 is equal to 500, this query was not able to use that filter index, and instead it went for a complete scan, that is a cluster index scan. And if you see here, we are reading close to the whole table. Like we performed an estimate of 419 rows, but the number of rows read is close to 15,99,877, which basically tells us that it has read the whole table and then it returned 0 rows. So if we look at the results again, the first query returned 10,912 rows and second query returned 0 rows. Now, if we look at the information here, what we are able to see is like the logical read for the first query is 34, and the second query is close to 10,856. Now, if you look at the logical reads and then compare it with the previous query, what we are able to see is like with a proper index, with a proper filter index, we were able to reduce close to 15x logical reads as far as this one. But this filter index actually created a huge performance issue as far as the second query is concerned, which performed close to 10,856 logical reads. So what we'll do now is like we will create an covering index, basically like cover both the predicate and then include the column that is present in the select list. So let's execute this query. And once the index is created, let's execute the same query here. Let's add an option recompile just to make sure everything seems to be okay. So what we'll do is like we will execute this with the execution plan on. And now if I look at this operator, what I'm able to see is like we are estimating 10,485 rows, and we are reading the number of rows read is like close to 10,912, and the actual number of rows for all execution is like 10,912. The estimate is not perfect, but it is like a small miss. So maybe like a miss of like maybe 400 rows, but SQL Server, to be frank, did not do anything extra. It basically read close to 10,912 rows and it returned those rows. So it was able to pinpoint the required rows and was able to return it. And if I look at the second query, which basically had the predicate of column 3 is equal to 501, what we can see here is like it estimated close to 461.326 rows. It basically did not read any rows, and it basically returned no rows. So let's look at the logical reads for this one. So what I'm able to see is like the logical reads for the first query is 36, and the logical reads for this query is just 6. If you see that again, it is 36 and 6. So it is very, very critical we add proper index. So we will have to go with a balance, because indexes are going to help your select queries, but it is going to have an impact on your write query. So it is very much required, and we need to understand like how critical is the select query, and then we basically have to add a proper index to that particular query. Maybe look at the existing indexes, and if you can modify the existing indexes to support all the queries, it would be of great help. And the predicate pushdown is something that we need to look at. Like even though we are doing an index seek or a cluster index seek, it is very much important to look at like the number of rows read. For example, it needs to be like same for optimal performance. It is not possible for to achieve that every time, but it is good if we can achieve that. That would be of a greater help. Thanks for watching. Have a great day. Jai Hind.